Welcome to our second lesson in Unit 5 on using intercepts. In this lesson, you will be finding the x and the y intercepts for a variety of different equations and functions, and you will be graphing linear functions by using the intercepts. So let's start off with some vocabulary again. First of all, we need to figure out what an intercept is. And an intercept is a point where the graph crosses the x-axis. So where it crosses an axis is an intercept. So the x-intercept is the point where it crosses the x-axis. It's also referred to as the x-coordinate, when the y-coordinate is equal to 0, that gives us our x-intercept. So on the graph at the right over here, the x-intercept is this point right here where it crosses the x-axis. And you can see on this particular problem, the x-intercept is -2, 0. So the y-coordinate is 0, and then the x-coordinate tells us where it crosses the x-axis. Likewise, the y-intercept is the point where it crosses the y-axis. That's the vertical axis. And for the y-intercept, the x-coordinate is 0. So in our example here on the right, we have a y-coordinate or a y-intercept of 3. So the coordinate is 0, 3. So just remember the opposite variable is 0 when you're looking to find an intercept. To find the intercepts from a graph, we want to find where the graph crosses the axis, like we explained in the last slide. So in this example, it crosses the x-axis at -4, and it crosses the y-axis at -3. So remember, the opposite variable is 0, so our x-intercept is -4, 0. Our y-intercept then would be 0, -3. From an equation, what we can do is we can use the cover-up method, and what the cover-up method does is you just cover up one of the terms, the opposite term that you're trying to find the intercept of. So if I cover up the y term, then I can solve for x. So if you just imagine this 2y not being here, so let me just draw a box in here. So if I cover this up and the 2y is gone and then solve for x, that would leave me with an x-intercept of 4. Dividing both sides by 3, that would give me an x-intercept of 4, 0. Okay, and conversely, I can cover up the x-coordinate or the x term and solve for y. When I do that, I end up with an intercept of -6. So I would get 0, -6. So you just cover up the opposite variable and then solve for what's left. To graph using intercepts, remember we only need 2 points to determine a line, so we can choose the 2 points that we have to be our intercepts, which makes graphing the line really simple. So the process we're going to use is we want to have the equation in standard form. Then we're going to find each of the intercepts. We will plot those intercepts and then connect them using a line. So here's an example. It says, use intercepts to graph the line that is described by the equation. So here we have an equation. It's already in standard form. So what we need to do is find what those intercepts are, and then we're going to solve and plot those intercepts. So if I want to find the x-intercept, that means I need to let y be covered up. So if I cover up my y term, that would give me an x-intercept of 4. So 4, 0 is my x-intercept. If I want to find the y-intercept, I just need to cover up the x term and solve for y, and that would give me a -2. And so then what I can do is I can go ahead and graph both of those intercepts. 4, 0 would be 4 to the right. 0, -2 would be down 2. So once you graph those 2 points, you can connect them with a line, and then you have your line. So we want to use intercepts again. Here's another example to graph the line that describes the equation. So in this problem right here, it's not in standard form. So the first thing we want to do is get this thing into standard form. So if I multiply both sides by 6, now I wrote 6 because I have denominators of 2 and 3. If I multiply everything by 6, all those denominators will go away. I'll get rid of all of my fractions. So when I do that, multiplying by 6, Let me just write this in here so you can see what's going on. The 3 will go away, and this will become a 2, and 2 times 2 is 4. When I multiply this one by 6, I will end up with a 3x right here. So let's just take a look. So this one gives me 4y equals, distributing my 6, I get a 24, and then half of 6 is 3, so I get a minus 3x. And then lastly, I want to bring my 3x to the left-hand side, or add 3x to both sides. And that gives me 3x plus 4y equals 24. So now my equation is in standard form. Then what I want to do is I want to cover up each term and solve for the opposite one. Okay? So to find the x-intercept, I'm going to let y be 0. You can cover it up, or you can just put in a 0 for y. That will give me 3x is equal to 24. And then dividing by 3, I get x is equal to 8. For the y-intercept, I want to let x be 0. So I end up with 4y being 24, and y is equal to 6. So now a y-intercept of plus 6 will be up 6 on the y-axis, and x-intercept of 8 will be 8 to the right on the x-axis, giving us a graph that looks like this. So here are 2 for you to practice on. Go ahead and find the intercepts. So show me what each intercept is. You should write the intercepts as ordered pairs, graph them on the graph, and then connect them, making a line, and bring those answers to class. See you next time.